All right, today we're jumping into something called Project Tapestry. It's a really bold new idea that wants to completely rethink how we build powerful, collaborative AI, not just in one lab, but on a global scale. Right now, if you're a country or a big research institution, you're kind of stuck with a tough choice. On one hand, you can tap into these massive centralized AI models from a few big tech companies. You get all this incredible power, but you also create what a lot of people are calling a strategic dependency. Or you can go your own way, build your own sovereign AI, keep total control, but man, it's a huge struggle to even come close to the scale and speed of the big players. But what if that's a false choice? What if you could actually have the best of both worlds, the massive scale of a global project and the complete control of a sovereign system? Well, that's the big, provocative question that Project Tapestry is trying to answer. So here's how we're going to break it down. We'll start with this whole sovereignty dilemma, then get into the project's really clever idea about data. After that, we'll see how the whole thing actually works. We'll also be real about the big hurdles they still need to overcome, unpack the 3 layers of sovereignty this could create, and wrap up with their open invitation for people to help build this thing. Okay, so let's dig into section 1, this sovereignty dilemma. The paper makes a really strong point. It says true AI sovereignty isn't just about getting to use a model that somebody else built. It's about having a real seat at the table when that model is being created, right from the very beginning, to help decide what it learns, what its values are. If you don't have that, you're not a partner, you're just a customer. So how in the world do you get a seat at that table? Well, this leads us to the absolute core insight of Project Tapestry. It takes something that everyone sees as a problem and flips it on its head. The idea is that having all this incredibly valuable data scattered across the globe, in different countries, different languages, under different laws, that's not a bug to be fixed. It's actually a feature, a massive strategic asset just waiting to be tapped into. The technical magic that makes this whole thing possible is called low communication distributed training. And what's so cool about this is that it lets all these different groups train one big model together without having to ship enormous amounts of data back and forth all the time. There was this key experiment called DiLoco, and it showed a model could get the same performance as a traditional system while communicating, get this, 500 times less data. That's a total game changer for making global collaboration actually practical. So how does it actually work? Well, it's this really elegant 3-step loop. First, every partner trains the model on their own private data, right there on their own systems. That data never goes anywhere. Step 2, instead of sharing the data, they just share these tiny, super efficient updates about what the model learned from it. And finally, step 3, a coordinator gathers up all these little updates, combines them, and forges a new, smarter, and more diverse global model that everybody benefits from. And this quote just nails the whole philosophy of the project. The point isn't to ignore the fact that all this data is different. The point is to build a system that actually gets better because of that diversity. Pulling in multilingual public records, unique scientific papers, and different cultural archives. That doesn't just make the model bigger, it makes it smarter, more well-rounded, and way more capable. Okay, so if the whole system thrives on diversity, what does the actual architecture look like? How do you weave all these different threads together into one cohesive whole? The basic building block of the whole network is the sovereign node. You can think of this as a single university, a national lab, or maybe a company that's participating. And here's the absolute most crucial rule. Their raw data, and all the intermediate stuff too, it never, ever leaves their own infrastructure. They have 100% control. Now, the way these nodes talk to each other is through what's called low communication synchronization. This is the how of sharing those updates. It's not a fire hose of constant information. It's more like sending a tiny, highly compressed postcard that just has the most important changes, the little deltas, all designed to save as much bandwidth as possible. And here's the really clever part for privacy. There's this cryptographic layer called secure aggregation. It's brilliant. It lets the coordinators see the final, combined update from everyone all mashed together, but it makes it mathematically impossible to see what any single node contributed. It's basically collaboration without exposure. Now, this all sounds pretty incredible, right? But the people behind this project are also really honest about the fact that this is not a solved problem. So let's get into the reality check, the huge engineering and research challenges they still have to figure out. They've got 3 massive open questions on the table. First, how do you keep the global model from falling apart when different nodes are updating at different times with wildly different kinds of data? Second, how do you make the system totally bulletproof against bad actors who might try to poison the model with bad data?
And third, what is truly the best mathematical way to combine all these updates when they're sparse and out of sync?
And this is a really key takeaway. Project Tapestry isn't some finished product they're trying to sell you. It's being presented as an open research agenda, a public invitation for the smartest people around the world to come together and help solve these really hard, really important problems. So let's say they can actually solve these challenges. What's the payoff? Why does all this hard work matter? Well, the project offers this really powerful new way of thinking about it as three distinct layers of sovereignty. The first layer is the most fundamental, national sovereignty. This is baked right into the system's design. Your data stays in your country. The privacy protocols protect what you contribute, and every nation decides for itself whether and how to participate. Layer 2 is cultural sovereignty. This is huge. Once that shared base model is trained, each individual node can then fine-tune it with their own safety filters, their own ethical rules, and their own alignment. This lets them create versions of the AI that actually reflect their local values, their laws, and their culture. And finally, there's industrial sovereignty. This is where a research hospital could take that powerful base model and build a specialized version just for diagnosing diseases, or a lab could build one for discovering new materials. It's all about building on top of that shared foundation to create real-world specialized value. And all of this brings us to the end of the white paper, which, isn't really an ending at all. It feels more like a starting gun. It's a direct, open invitation to come and help build this future. And they're very specific about who they're looking for. They're calling on researchers to help crack those tough open questions we just talked about. They need engineers and builders to actually construct the production-grade software. And they need institutions. We're talking national AI programs, top universities, industry labs, to step up and become the founding nodes of this new network. And this isn't just a dream. They have a practical, step-by-step roadmap to get there. Phase 1 is all about building a small prototype and getting the open source code out there. Phase 2 is about growing the network, making the models bigger, and adding more advanced features. And the long-term vision is to adapt this architecture for whatever comes next, like the giant world models people are talking about. The paper's final sentence, I think, just captures the sheer scale of the vision perfectly. The goal here isn't just to find a new trick for training models. The real ambition is to build a lasting, collaborative foundation for a completely new way of developing AI, one that's both open and sovereign. And that really just leaves us with one big, thought-provoking question to chew on. If we could move past the way things are done today, what would a truly collaborative AI future, one built by many different hands from all over the world, what would that future actually look like?